All right, so let's take a look at this rewind problem. So number 5 says a minus 17 is greater than or less than. Right, that's a greater than symbol because it's facing, the bigger side is facing the left side, so greater than. All right, again, greater than or less than, the way I remember it is the less than kind of looks like an L and the greater than does not, okay? Otherwise people look at it like maybe the alligator. So the bigger side is facing the a minus 17. I'm gonna write it here to give us a little more room. How am I going to isolate that a? I'm going to add 17 to both sides. So I have negative 16 plus 17 on this side, which is going to end up giving me a is greater than positive 1. The signs are different, so I subtract. 17 minus 16 is 1, and it stays positive because 17 is the bigger number, and 17 has a positive sign. So a is greater than 1 means I'm going to go ahead and put an open circle at 1. And then since a is greater, it's going to go this way, and my arrow is pointing towards positive infinity, so all the way over here to positive infinity, which means it can be any value from 1 all the way to positive infinity. So could it be 10? Could it be 1,000,000? Yes, it could be any of those things. Could also be all the decimals and all the fractions that are in between. We just don't put those all in a number line. All right, so today we're going to talk about how to solve these when they involve multiplication and division. And there's a little trick here that we're going to get to in just a second, but we're still doing the same thing. So we're still solving inequalities like we would algebraic equations. The only difference is that instead of an equal sign, I have a less than sign. So this says 12x is less than 48. I still want to isolate my x, which means I'm going to divide by 12. Because there's no symbol here, I assume it's multiplication. So to undo or to eliminate multiplication, I divide. If I divide by 12 on one side, I do it on the other. And I end up with x is less than 4, because 48 divided by 12 is 4. So when I go to graph that, I'm going to put an open circle at 4. And my arrow is going to go to the left, because x is everything smaller than 4. So x is all that stuff all the way down here to negative infinity. So all the way down to negative infinity. X is less than 4. Okay, what's happening here? So again, people get psyched out with these because they kind of look like fractions. People don't like fractions, but we are not afraid of fractions in here. We know that to get rid of anything that looks like a fraction, I'm going to write that as 1x over 3, which is less than 2. And to get rid of that looks like a fraction, when we're multiplying by a fraction, I just multiply by its reciprocal. Just as a reminder, if it's addition or subtraction, I still add or subtract using inverse operations. I only use the reciprocal when I'm multiplying by a fraction. So what would I multiply by here? The reciprocal of 1 over 3 is 3 over 1. And again, we have to do the reciprocal because the 3 is currently in the bottom, and we want to cancel it out, meaning we need to put it in the top. So if I multiply by 3 over 1 over here, I'm going to do 3 over 1 on the right side. I don't really need that 1, that's a placeholder, but I'm going to keep it there just so I can keep track that I'm doing the same thing on both sides. So I'm going to make my page a little bigger. All right, my 3's go away here, and all I'm left with is 1x over 1. I don't need any of those 1's, so I'm just going to write that as x. On my right side, 2 times 3 gives me 6 over 1. Again, I don't need that 1, so I'm just going to write it as 6. So x is less than 6. So I put my open circle at 6, and then my arrow goes over to the left side. So x is less than 6. X is all the values less than 6 going all the way over to negative infinity. So all the way over to negative infinity. That means it can be anything that's highlighted by that blue line, and then all the numbers continuing down to negative infinity. So x can be a lot of stuff. Again, that's why we're graphing all of these, because otherwise your option would be to just write all of them in a list, and we don't want to do that. That would take years. Okay, so dividing and multiplying by a negative. So this is the little trick I was talking to you guys about. So when I divide or multiply by a negative, my sign, my greater than or equal to, less than or equal to, less than or greater than symbol, my inequality sign has to flip. So a less than becomes a greater than becomes a less than, and vice versa. So what that looks like is if I divide by a negative 12, which is what I would have to do here, immediately my sign goes from facing the right to opening to the left. All right, so when you divide by a negative, that's the opposite of a positive, so that's how I kind of remember it. If you're dividing by a negative, that's kind of opposite, so I want to make it the opposite sign. So it was less than, and now it's greater than. So I divide by negative 12 on this side, x goes by itself, and then I divide by negative 12 on this side, and I get negative 4. So x is actually bigger than negative 4, which means I'm going to put my open circle at negative 4, and then my arrow is going to go to the right because x is all the bigger stuff. So when you are multiplying or dividing by a negative, your sign must flip. All right, so your less than sign would become a greater than sign in this case. And the reason for that is, give me some stuff that's on this highlighted line. So pick a number here. Let's pick, for instance, let's pick 3. All right, if I go back and plug that in, negative 12 times 3 less than 48. That ends up giving me negative 12 times 3 is negative 36, which is less than 48. That's true. That is a true statement. Okay? If I had not flipped my sign and I had put my arrow, I'm going to write this arrow here, but this is not correct, so we're going to ultimately erase it. So if I had not flipped my sign and put my arrow this way, pick a number that's in here. So let's go with negative 5, because it'll be a little bit easier. So negative 12 times negative 5 is less than 48. When I multiply two negatives together, what happens? It becomes a positive, because two negatives multiplied will give me a positive. So that gives me 60 is less than 48. Is that true? No, that's not true, right? 60 is not less than 48. That is not a true statement. So all this stuff in the green arrow would not be right. So that's false. So the reason that you flip that sign when you're multiplying or dividing by a negative is because two negative signs are going to cancel out to become a positive. So all these numbers, as they're getting smaller on the number line, when you multiply or divide them by another negative, they're actually getting bigger. So that's why you have to flip your sign. So be really, really careful with that. People forget it all the time. So if you're multiplying or dividing by a negative, flip your sign. Okay, be careful with that with your practice. You have 4 practice problems right here. So you have 4 practice problems right here, and you need to be really careful with your negative signs. Go ahead.